Hi guys, good morning. I hope that's not too loud. Good morning guys, and thank you for joining today's webinar series. To be exact, today's session's 15 webinar series. My name is Adrian, and today I will be your host and also your presenter. I will be, am I too loud, Shaman? I will be your presenter for today, and I will be sharing with you on what you need to learn basic Arduino and also basic electronics. All right. The key title here is that we will be using Tinkercad, and the sole purpose of this workshop is to guide beginners in electronics and Arduino. Okay, good morning and thank you for joining again. A bit about myself. If you don't know me, I am a DIY enthusiast. I love to build stuff. I especially on the revolve around Arduino. I began my DIY journey with Arduino actually. It's a little late for me to during my DIY journey. I pick up during my university time instead of my high school period. It's been a while now, and it actually changes me in the scope of DIY. So today I'm here to share with you on why you should pick up Arduino and a lot of things about Arduino as well. And I hope that I'll be able to answer your questions. All right, I encourage you to ask me as many questions as you can. If you have something that you would like to know about Arduino or Tinkercad, please, this is the opportunity for you to ask. Okay, so I see people are pouring in, and all right, we only have 1 hour in this session, so let's get started with the agenda. I'm gonna cut the music now. All right, a couple of items that I would like to cover today. It includes what, why, how, where, when, which, all the questions that you have around Arduino. All right, these are the questions that you can answer to your friends, to your family, to your students. All right, and I will try my best to give you these answers. You have a lot of questions. I see some people have questions for me already. Great. If I didn't answer your questions during this session, I encourage you to ask me. All right, I highly encourage you guys who are here to interact with me. This is a chance to interact with me. Ask me questions about Arduino. Ask me ask me about how I make stuff, how I make stuff with Arduino. All right, things. Just ask me. Okay. So first, I'm going to cover what is Arduino, obviously, because we are going to focus more on Arduino. That's today's topic. And then why you should learn Arduino, where and how you can learn Arduino. So before we learn Arduino, what do we need to know? A couple of basic electronics, and then we will move on to Tinkercad simulation. When can I use Arduino and which Arduino should I get? Okay. This session, it's meant for beginners. And if you have a laptop right beside you with internet access, please, I encourage you to join with me during when I demo. I encourage you to try it out with me as well, so that you get firsthand experience on how to run simulation using Tinkercad. Okay. So to the big question, what is Arduino? Arduino, it's an embedded system on the left picture over here. That's the picture of the first Arduino Uno. All right, you can see that the microcontroller is huge. All right, there are a lot of components on a single board. Okay, this is called an embedded system. It means that there are multiple components and features all embedded into a single board. All right, it provides you different features. It can do a lot of things basically. All right, it has a microcontroller, it has some RAM, and then it has different built-in features. Over here, I have a Maker Uno. It actually serves the same purpose. Actually, both are the same thing. I'm gonna tell you why there is different types of Arduino as well. But basically, I'm not gonna go through every single part of the components, because today's session, it's meant for you to explore these features. All right. Normally my approach is that I will explain to my student, oh, this is smart, this is microcontroller, this is the buzzer, this is the, what different components. But today I'm going to do it a little bit different. I'm going to like, hey, let's go and just explore it, and then you will find out what are these components on the board eventually. Okay. So Arduino is an open source electronic platform. The highlighted word is open source. What is open source? Open source means that the schematics, the programs, everything about this Arduino is actually accessible to everyone. You can go and download the circuitry, the schematics. You can build your own Arduino at home. All right. Everything is accessible to everyone. It's open source. Okay. The source is open to everyone. So why is this good? Why am I highlighting this? An open source actually enables community to build more creative projects and explore in the deeper, in the in-depth solutions. They can find solutions by diving into the source code, by diving into the schematics. They can build different types of projects. That's why Arduino is so it booms, because it's mainly open source. The community love it because it's open source, and it allows people to get creative. And Citron also have our own maker Uno, which is based on Arduino Uno, inspired by Arduino Uno with more features. So because again the schematics is open source, that's why we are able to create more different types of Arduino. Okay. Next, it consists of an easy-to-use hardware. Like I said, the hardware is built for beginners, from beginners to intermediate level to advanced level to engineers. The range of its capability is very wide. From primary school, I've seen primary school students using Maker Uno or using Arduino, right, until engineers. So again, it's for you. It's easy for you to use and program. And it also comes with its own software, which is Arduino IDE, but I'm not going to cover Arduino IDE today. That allows you to program your physical Arduino. You don't need this today. You don't need a Maker Uno or an Arduino board with you today. All right, I'm assuming you have nothing. You only have a laptop with an internet connection, and that's good enough. Number 3, it's designed to make electronics more accessible to everyone. Everyone, I mean you, me, everyone, anyone, right, with different background. You don't have to be a diploma engineer. You don't have to have a degree in electronics engineering. You, all right, anyone, an artist, a musician, anyone are allowed to use electronics using Arduino. It's built for them, actually. All right, it's built to make it easy for people to learn. Okay, before I proceed to my next slide, I see some questions in the comment section. I'm just gonna go ahead and answer it. I believe some of you are teachers and students. You are here to participate and learn, and at the same time, you are also asking if there's a registration link that you have to register for today's session to receive the e-certification by the end of this session. You don't have to register. You just have to fill in the link that I'll be sharing with you by the end of this session. So stay with me until the end of this session. All right. You have to give some feedback, and after you fill in that form, you'll be able to receive your e-certificate. Okay. Of course, there will be a mini quiz during your when you want to fill in that form. There's a mini tiny quiz. You have to answer it correctly to be able to receive your certificate. Answer it wrong, and then no, you won't be able to receive a certificate. But the question, I promise you, is very easy. Okay. All right. Yep. Some commented that primary is starting with microbit. Yes, microbit is also an embedded system. It's built to make programming easy. And Arduino as well. So Arduino started first, and then later on microbit come in, and then like, hey, I can do it better than you in primary school standard. But again, both serve similar purpose. It's meant for electronics to be easy and teaches students to be creative. All right. Okay, One more questions before I proceed to the next slide. What's the difference between Arduino Nano, Uno, Mega, Raspberry Pi? How do I choose to fit my project? That's a very good question. I'm going to leave this question to the end of our agenda today because we have a lot of items that we have to cover. At the end of this session, I will also answer you which Arduino should you get, which Arduino it's for you. All right, that should probably answer your question on how do I choose to fit my project. Okay, stay tuned, stay with me until the end of this session. Okay, all right, hold on guys. Okay, let's move on. Why should I learn Arduino? If you're a beginner here or if you're a teacher and you're trying to look for answers to convince your students why they should learn Arduino, okay, to be blunt, because I know it's in our textbook, it's in the RBT textbook, we have to learn electronics, but there's a better reason for it, all right? Once you understand Arduino, you will be able to understand that it actually makes sense to learn Arduino, right? Not just because of exams, but because it improves the way you think and the way you see things. Number one, Arduino has a low bar of entry. You can learn electronics easily. That's why today it's in our high school textbook. All right, it's in the RBT textbook because it has a very low bar of entry. I understand that Malaysians, our students are still adapting, our teachers are still adapting to this new topic. All right, it's not easy to pick up a new topic and just understand it overnight. So it takes time to understand Arduino and takes time to pass the knowledge to your students. So that I understand it well. Even though it's low bar of entry, it still need time. You still need time to learn and pick up. Okay. A simple comparison between RPT and KH is that KH still covers electronics chapter. All right, you still learn the components, you still learn resistors, you still learn how to solder, all this stuff. But one thing is missing is that there's no programming, and programming is the one that actually teaches students to do problem solving. All right, so that's the only difference between these two topics. And of course, RBT covers a broader range of electronics. It covers microcontroller, microprocessor, and all these things. So again, lower down your level, right? Make yourself feel comfortable when you learn Arduino. Number two, it won't burn a hole in your pocket. It's accessible. It's very cheap. You don't have to, like I said, you don't need a degree or you don't need a degree in engineering to learn Arduino. And when you go into such a high level, you will expect that, electronics, if I want to learn something, it should be very expensive. But in reality, Arduino, no. You can get it like 20 ringgit to 30 ringgit for an Arduino, and it's very accessible. Learning electronics shouldn't be expensive. The components should come cheap. All right, cheap as in within range for you to build your projects and learn the fundamentals. It shouldn't come expensive unless you are planning to build an industrial grade project, then it will get expensive. But for beginners to learn something simple, it shouldn't be expensive. Below 50 ringgit is enough for you to learn everything you need about fundamentals of electronics. Number three, it enhances creativity and increases possibilities. So I'm just going to give you an example. If you're an artist if you're a graphic designer or an artist, right, you love to do art and your only skill is art. Right? You know the way of the paintbrush, you know how to make art. Let's say if you learn an additional skill, Arduino, and it opens up your creativity, it opens up the possibilities of your art. You no longer work art with just paintbrush. Right now you have an extra skill set, which is electronics and Arduino. You will be able to integrate electronics into your art, and voila, you got the different types of products. Okay, so Arduino actually extends your creativity in whatever you already know. It enhances your creativity and it increases the possibilities. That's what I'm trying to say. All right, it's multidisciplinary. When you learn one knowledge A and knowledge B, you mix it together, boom, you got a knowledge C. So Arduino is one of it, and that's why I encourage you to learn Arduino, learn the fundamentals, learn the basics so that you will be able to see possibilities. If you don't learn it, then you won't be able to see it. Right? I'm talking about the fundamentals, not the advanced level yet. Okay, number 3, it activates problem-solving capabilities. Again, because it covers a wide range of audience, from beginners to intermediate level, engineers, students, different levels. And when you move from one level to another, you will face different types of challenges. And of course, with these challenges, you are forced to solve problems, right? We humans love to solve problems. We have to constantly solve problems, and electronics is a good platform for you to practice your way of solving problems. Okay, so this is the 4 main points, but of course, the community is one of it. Arduino community is one of the biggest community around the world, right? If you know where to find them, if you know where to join them, they are a very fun group of people with a lot of exciting projects and ideas. They have the most craziest ideas around. And if you manage to join them, you'll be able to see their creations, very crazy creations with Arduino and also open source platforms. All right, they are the people that are there to help beginners to learn. So join the community as well. All right. So I know I'm dragging this a bit long because this is some of the important key points that I would like to deliver to you so that you understand that why I should learn, and you will be able to explain it to your students as well. But let's move on. One question from the floor. I'm just gonna go ahead and answer it. Actually, I have 2 questions, but one I will reserve it for later. Arduino mainly served for education purpose, or Arduino suitable for heavy industrial automation use, or smart home? Arduino Arduino because it's built to be easy. So yes, it serves for education purpose. All right. It allows students to explore and build stuff like smart home automation system for student level and for university level. If you're going up to industry level, then you have to look at your application. All right, is this enough to be implemented into your industry? Okay, if you are looking at very heavy duty industry automation kind, right, you may need to think about using those industry grade microcontrollers to be implemented. But it really depends on what kind of application you are dealing with. So I'm gonna leave that for the last part in this session. Okay, but yes, education purpose, it's Arduino, it's all about education. All right. How and where can I learn Arduino? Number 1, YouTube. YouTube is our favorite, right? Next to Google, YouTube is our second favorite. When we want to learn something, we always look up to YouTube. Okay, hey YouTube, I want to learn this, I want to learn that, because we are all visual learners. Some of us, most of us are visual learners. We want to see things to believe it. We want to see to learn. So YouTube is the best place for us to learn how to program an Arduino and how to build stuff with Arduino. Number 2, Instructables. Number 3, Hackster. And number 4, Citron tutorial. So 2, 3, and 4 are actually almost similar. They share, right? They are like a blog or a place with a lot of instructions, tutorials built for people who want to build stuff. Okay, for a maker, you don't have to build something from scratch. I'm not gonna say, hey, this is a Maker Uno and this is some sensors, and then go build your stuff. No, that's not the way to do it. All right, the easiest way to practice on making things is that you look up to these websites, right? YouTube, Instructables, Hackster, Citron tutorial. Copy and paste those projects. Build exactly the same project. Get it to work first. Once you get it to work, sparks your interest, you're very interested, you're very happy with what you have done, Then you move on to innovation. You start to tweak stuff. What if I remove this? What if I add this? What if I remove this line of code? You work backwards. You don't work from front to, you don't work from bottom up. You work from the back to the front. So this is what I'm going to do later in Tinkercad. All right. I'm not going to say, hey, here's an Arduino, here's an LED, make it light up. Okay, write the code, make it light up. No, I'm going to do it differently. I'm going to say, here's your code, here's your Arduino, and here's everything you need. Now, subtract and learn from there. Number 5, join a community. This is where you learn about Arduino as well. And also Tinkercad, which is what I'm going to cover today. So here are some of the, the logos. It may be familiar with you, like Instructables. I'm from Cytron, by the way. So we also have our tutorial page. We will try to answer your questions. If you have a very difficult tutorials that you need help with, you can ping us. You can join our community, ask us questions in those groups, and I'm sure we'll be able to help you. All right, and Hackster, and also last but not least, Tinkercad, which is what I'm going to cover today. Okay, so let me see if I have any questions right now. Okay, let's move on. Some of the questions, if I didn't answer you immediately, means that I'll be answering your questions in the later slides. So I'm not going to drag, but bear with me, stay with me for a little while. So before we start programming with Arduino, of course, we don't jump straight, Arduino programming. We need to learn a little fundamental of electronics. Normally during my class, in a physical class, when you teach Arduino in a physical class, you have to have some ground rules. You have to make sure that no water is on the table. You shouldn't push around when you're dealing with electronics, and then you have to comfort the students that, hey, you won't get shocked. You won't get shocked. This is just DC. Right, it's not AC, right? It's very low voltage. You have to comfort your students and set some ground rules in your classroom. And of course, once you got the ground rules set, you have to teach them some fundamentals so that they don't break your Arduino in your school or in your classroom, right? You don't want them to, don't follow the rules, right? Go against electronic rules, right? Short something, because Arduino, it's not invisible. It can still break, right? If you force it to break. So there are a few simple things that you have to make sure before the students get into the physical project. Tinkercad, what I'm going to do later is that it's a sandbox. It's a very safe environment for you to explore and destroy things. And you won't waste money by destroying things in the simulator. So it's a good place for you to try it out as well. All right, so I'm going to cover a few basic electronics. All right, it won't take long. Bear with me. So short circuit. I'm going to do a comparison between short and open circuit. What is short circuit? What is open circuit? We always, right, in our terms, right, in our terminology, we always like to say, hey, short circuit ready lah. Your brain short circuit or things short circuit ready. We like to say short circuit. Right? But do we really understand what's the meaning of short circuit? Is it like the thing spoiled, an electronic device spoiled, it always has to be a short circuit? Right? Does it have to be a short circuit? Can it be something else? Yeah, it can be something else. All right, the microcontroller can be, fried, or it can. But normally, electronics fried because short circuit. Okay, this is an example. Short circuit, when you have a battery and you have a light bulb, you have an LED, your current flow in single direction. But if there's a single tiny connection in between that blocks or jumps your current to the other side, so your current won't flow through your LED. It will choose the least resistance path, and then this is how the current will flow. It will flow back to the battery. So the positive back to the negative, your battery heats up, and then boom. All right. So short circuit, this is called short circuit. Another example is if I have an electronic board, let's say my Maker Uno, my Arduino, right? You see there are a lot of bare circuitry over here. it's not wise to use water and pour it on top of it, because of course you create short circuit. You are creating connections, current flowing from one point to another point unnecessarily, right? Because electricity conducts through water, and if you drop a water on top of an Arduino, then you're gonna destroy something. So this is short circuit. Okay, you don't want the circuit, your current flows from one direction to another direction, to another location with a specific location. So you don't want them to go haywire and just flow anywhere, everywhere you want. You don't want. All right, so that's the whole idea of short circuit. And what is open circuit? Very simple. Open circuit means that the circuit is not complete. It's open. The current doesn't flow. It's incomplete. Basically, it's an incomplete circuit. So with an incomplete circuit, you can't really light up your LED. You can't really light up anything. So if you're building a project and then you see, hey, why my LED is not lighting up? All right, number one, is it open circuit? You have to check. Number one, is it open circuit? If it's short circuit, you will be able to know, all right, things may burn or things may heat up. Your Arduino may heat up very, very fast. So in Arduino, when I teach students, there are a couple of times that I face students shorting components, and the first reaction that I almost instantly have whenever I realize, oh, short, I pull out the wire, I pull out the power immediately to save my Arduino, to save the components as well. Okay, how do you know it's short? You will use your fingertip and you touch the components. Hey, oh, this is very hot, something is wrong. Unplug the USB immediately. All right, this is one way to identify what is shorted. But normally, if it's not heated up, means it's exploded already. So again, be safe. Don't short your circuit, and check your circuit before you connect it. Of course, Arduino won't explode. Right, I'm just over exaggerating, but it won't explode. It will just heat up. Okay, and when you talk about short, open, there's of course another one, closed circuit. Right? If you have an open circuit, you have a closed circuit, and a closed circuit means it's a complete circuit. Right? The current flows completely, and then you light up your circuit. Okay, this should be covered in your textbook. I think it's covered in KH, in physics, and also in RBT. So let's take a look at some of the questions before I move on. Okay, any offline PC software or programming this Arduino? Yes, the Arduino IDE. So if you go to the Arduino official website, you can download and install the official Arduino program. It's offline. You don't need internet to use it. Tinkercad is a simulator, so you unfortunately they don't do it offline, so you need internet to use Tinkercad. But the original software for Arduino is offline. Okay, and then do Arduino coding have website like Stack Overflow? You mean Stack Overflow? So they have their own forum. Arduino have their own forum. You can go and check out Arduino forum, and then they have people answering questions in Arduino. So there are a lot of blogs about Arduino, all right, tutorials, answering questions like white papers. So there are a lot of these resources out there you can get used for when you're building your projects. Right? It's similar to Stack Overflows anyway. All right, let me see. Okay. What is the electric component that can prevent short circuit? Right, the only way to prevent short circuit is to not short the circuit. Okay, don't drop conductive material in between connections, and yeah, don't spill water on your Arduino. Don't drop a piece of copper wire, exposed copper wire on your Maker Uno or on your Arduino, and connect your circuit carefully. All right. So series versus parallel. What is series? What is parallel? Take a guess. Which one is series? Which one is parallel? It's very obvious, right? So parallel means that it's parked parallelly, like you park your car parallel parking. So you have your two LEDs in the parallel direction. The one on the right is parallel, and the one on the left is series. Okay. In series, components are arranged in a chain. current flow in a single path from positive to negative, and then electrons from negative to positive. And for parallel, there are two or more paths for current to flow through. So it will flow through the first LED, and then it will also flow through the second LED. So for a series circuit, if one LED blows, pop, the whole circuit will just, the other LED won't light up at all. It will just stop. And for parallel, if another LED pop, the other LED will still light up because it becomes a series already. The other LED destroyed, okay, it's fine. The battery will still be able to supply current to the another LED and then back to its negative. So this is the difference between series and parallel. I'm not going to dwell much into it, but it's an experiment worth trying when you teach your students in electronics. Number 3, voltage, current, and resistance. So before we move into electronics Arduino, we need to understand the concept of voltage, current, and resistance. We often get confused between, hey, what is voltage, what is current? Resistance, we more or less know what it is. All right. So in this art image over here, very straightforward. The voltage job is to push the charges, electrons through a closed circuit. Right? It push the amp through a very thin wire. And then the current job is to carry electrical charges through the wire. But the resistor's job is to resist the current from flowing. Okay, so these three work hand in hand, right? Without the resistor, what's gonna happen? The amp is gonna run through the wire, right? It's gonna run very fast. The voltage is gonna push current, and then current is gonna run very fast because resistance is not there. And then, of course, a circuit won't work if there's no voltage or current. To put it in the electronic form, it will look like this. Okay, over here we have our voltage, we have our current, and we have our resistance. It's the same as this, but into this. Okay, we have voltage, current, and resistance. Voltage, current, and resistance. I have same voltage pushing, and then we have different current. Why? Because our resistance is different. We have a very high resistance, and we have a very low resistance. The one on the left is low, 220 ohm. That's the unit. And the right one is 1000 ohm. I always show this to my students because I don't want them to, destroy LEDs, burn LED, and also ask me, hey, why your LED doesn't light up? Okay. And now the first thing I want to say is, hey, did you check a resistor color code? Did you check your resistor's value to make sure that you're using the correct resistance? If your resistance is high, your ohm is going to pull harder, and then the current is gonna, have trouble going through the wire. And then that's why the current becomes lower, and then your LED is dimmer. And if your resistance is lower, means that it doesn't pull that tight. So the current is going to run past freer. It's gonna run past freely, and then the LED is gonna be brighter. But if you don't put resistance at all, what's gonna happen? Your current is gonna be like, oh, free, I'm free. It's gonna run through the wire, and then boom, the LED is gonna burn. Right? So 2 rules when you're connecting a simple circuit like this. You need a resistor, but you don't need a too high resistance, because you either burn it if you don't put a resistance, or your LED won't light up because your resistance is too high. So find a good resistance value and light it up. If you're interested in the Ohm's law, then this is the formula: V equal IR, voltage equal to current times resistance. But I'm not going to delve into this, like what's the formula about. But basically, these are the 3 things that you need to know. All right. Voltage, current, resistance, series, parallel, and then short versus open. The rest, actually, there are a lot of other things that you need to know about electronics fundamental before you work with Arduino, the bare Arduino, the physical Arduino. But the remaining things that I won't cover it today, I want you to experience it in Tinkercad, okay? Because you can learn how to destroy things, you can learn different kinds of theories in Tinkercad by experimenting it yourself. So again, if you have a laptop with you, join me in Tinkercad right now. This is the link that you should go: www.tinkercad.com. If you just join, you are in the your timing is very nice. Means that you get to join the Tinkercad session. I'll be showing you how you can learn using Tinkercad, but I won't be showing you, oh, hey, this code should do what, this code should do what. No, I won't be teaching you that low detail yet. I will tell you how you should approach when you learn it yourself. Because of course I won't be able to teach everything today. So I hope that you will be able to explore it yourself after this. All right, go to Tinkercad, and this is what you will get. Again, you will need internet connection. You will need internet connection, and you will need to sign up an account. If you go to Tinkercad, this is what you will see. All right, you'll be able to see this. Okay, there are a lot of in our past webinar series, we actually talk about Tinkercad with microbit, Tinkercad with 3D modeling, and today we're going to talk about Tinkercad with Arduino. So first things first, you have to sign up an account and then click sign in. I already have an account, so I'm just gonna go straight ahead and log in to my account. Simple, right? But yes, you need internet to sign up and to log in. After that, you will be able to see there are 3D design, circuit, code blocks, lessons over here. We have covered 3D design. You can create 3D models in Tinkercad. Then there's this circuit. You have to try. This is what we are going to cover today. And of course, you can create projects and you can start a class in Tinkercad. I'm not going to cover all these other features today, but I encourage you to explore it. All right, if you are running a class, explore the classes features. All right, there are a lot of features. So go ahead and click try circuits or create a new circuit. Once you click try circuit, it will immediately show you an existing circuit, right? Okay, this is the circuit that you can try first for electronics. Okay, then it's very intuitive. It comes with an instruction guide over here on the left side. It will tell you, okay, first you will need to test a circuit. Well, this is the simulator. You are already in the simulator, and then you just need to click next. It's something similar like Scratch programming. If you learned Scratch before, it comes with a built-in instructions. It teaches you what's the step-by-step on what you need to do. If you are not able to read well yet or understand well, just follow the images over here. Right? Ask me to start simulation. Click start simulation. So I'm just going to click start simulation, and then there you go. My LED light up. And then this is the simulator time, means that how long I'm simulating this circuit. Okay, it's been 8 seconds now. And then now I'm going to go next. All right, congratulations, you simulated your first circuit. All right, it's as simple as that. So you basically connect these components on the right side here. Just drag this component here and then, connect your components together by joining and pulling them together. Once you build your circuit, click start simulation, and there you have it. You are already simulating a circuit. This is good, particularly for younger students, because you don't want them to destroy LEDs or burn themselves or scratch themselves or poke themselves. For students, below 5 years old, this is a good platform for them to try it out. And of course, it's also a good platform for you to test out your circuit before you purchase the actual thing. Okay, so I think we have some questions here. Yeah, only one questions. Can Tinkercad convert SPICE to CAN? It can export to Eagle files, right? Eagle.brd for circuit board layout. For SPICE, no, not that particular format. Okay, if you're working with Arduino, then yes, you can export it to the .ino format for your Arduino programming. But other than that, right, it's worth exploring. Give it a try. For SPICE, so far I have not tried working with PSpice. All right. Oh, can I get a link for Tinkercad? Okay, Tinkercad. Here's the link. Let's move on. So once you're done, click done, and then you can continue. You can continue with the lessons, or you can explore the projects immediately. So this is what I'm going to show you right now. Okay, we are not going to follow with the guided lessons. We are going to go on our own pace. All right, everyone have their own pace. If you have a group of 10 students in your classroom, don't expect all 10 students to learn the same circuit at the same time. It doesn't work that way because every students have different pace. All right, some students learn it in their own pace. Every student learn at their own pace. So go ahead, create a new circuit. Click create a new circuit. Every student go ahead, create a new circuit, and then explore this circuit. So over here, there's basic components. Let me see. I'm not sure if you guys can see it. Basic components. We have Arduino, we have microbit, and then we have circuit assemblies. Today we'll cover Arduino. So go ahead and click Arduino. All these Arduino circuits are already connected to something. Okay, it's already connected there. Everything is already connected. Once you, okay, example, once I drag this circuit out, okay, it's a bit big because I enlarge it. It's going to look like this. The circuit is already connected, and when you click code over here, it's going to show you in block programming. So this is something similar to Scratch. For younger students, you can connect your circuit by just drag and dropping these blocks and connecting them together. Over here, this program allows the LED to light up for 1 second and turn off for 1 second. All right. Again, the approach is different. The code is already there when you drag the circuit. The students should be able to see this program immediately. Right? You're not doing the other way around, like, hey, this is a book, go and build this program. No, right now it's, hey, this is the program, go and explore this circuit, go and destroy this circuit, go and change the number. So what students should do is, what if I change this to 5? What if I change this to 2? What's going to happen? You ask them these questions, right? And then you ask them, and then they will think, oh, my LED is going to light up 5 seconds, and my LED is going to turn off for 2 seconds. And I say, is that true? Click Start Simulation to find out. All right, once they click Start Simulation, your circuit should run, and then it should light up for 5 seconds, and then it should turn off for 2 seconds. So this, you create an environment for them to, be brave and explore different things, explore their code by modifying their existing code. Okay, it's a different approach. Again, we want them to be creative and be daring to change those codes. All right. In my past experience, all I did was, okay, here's a book, here's some programs, go ahead and try and program according to this book, copy and paste. It's good, but after that, not many students will move on to the next step, which is copy, paste, modify. They will rarely go on to the third step to modify those code. Right now, this approach is that here's the code, modify. Okay? When you modify, you understand the code. When you copy, you don't really understand it, but you will be able to see it functions. Okay. All right. In the Arduino Tinkercad program, you can also choose your program to be in different forms. Okay, let me zoom out. Okay, I have to stop my simulation before I can choose a different set of programs. So there's blocks plus text, and there's text. If I click block plus text, it looks like this. When I drag my code into this, this block, I connect them together, it's going to add a line into my program. Okay, if I delete this, it's going to remove the delay. And if I add it, it's going to add a line of code here. Very intuitive, right? It's very simple to use. And again, we want students to understand what's happening here. Once I understand the block, I want to understand the text. So I will just I put this, and then oh, so wait 5 seconds is delay 5,000, right? Easily I'll be able to understand. Oh, this is right. It's apple to apple. You will be able to understand it very easily. Okay. So yeah, this is the platform for you to teach and learn Arduino. I'm not going to cover everything again. There are so many things that you can do over here, but let's go on to another project. So this is a simple LED. All right. If you want to connect your circuit with an Arduino, all right, it looks similar. You have these headers, these black color headers over here. And then you basically just connect wire from here to your resistor to your LED, and your LED back to your ground, 13 to GND. Okay, and if you're programming pin 13 over here, you will have to write 13 here, 13 here, and 13 here. You'll be lighting up pin 13. All right. So I'm gonna delete this. Click on the object and then just click this trash can, delete. Okay, if you delete the Arduino, that's the main component. It's gonna prompt you, okay, are you sure you want to delete this? It won't be restored. Just click OK and delete it. You can type on the keyboard and just delete. So now let's look at a different project. Just now we look at blink LED. Now we will look at, if you want to learn breadboard, okay, over here there's breadboard as well. But let's move on to something more complicated, analog input. During my introduction, I didn't really talk much about analog versus digital. Okay, but this is also one of the key points that you have to highlight to your students. What is the difference between digital and what is the difference between analog? All right, to put it simple, what you saw just now, LED blinking on and off, that's digital. You either on or you either off. As for analog, you can, control the voltage level. You can go like in between levels. It's not just on and off anymore. It can be in between. It's like turning on and off a fan, but instead you can control the speed of the fan, or you can control the brightness of an LED. So this is somewhat similar to analog. Okay, so that's basically the difference, either on and off or in between. In this circuit here, it's going to read analog signals. And why do we need to read analog signals? Okay, in electronics, we deal with a lot of sensors, and sensors actually represents a human sensory system. Right, we have nose, we have taste, we have hearing, we have sight, right? And all these sensors are actually just trying to do these jobs, right? It's trying to hear how loud is loud, how bright is bright, or how hot is hot. So we use sensors in electronics to determine these conditions. How hot is hot, how bright is bright, things like this. And when we want to use these sensors in electronics, we have to use analog signals. Okay, these signals comes in analog. You don't use digital to determine how hot is hot, right? If you use digital, it's gonna tell you very hot or not hot, very hot or not hot. Only two results. But if you use an analog signal, you will be able to determine very hot, partially hot, hot, cool, very, very cool, and then extremely cool. You will be able to, have different sets of parameters based on the analog input. I won't be connecting a temperature sensor now, but this is a simple analog input signals where you connect your 5-volt into this potential meter. This is a potential meter. When you click the components, it's going to show you potential meter. It has a 250 kilo ohm. It's a resistor. A potential meter is a rheostat. It's a variable resistor. You can control the resistance value. Once you simulate this, you can control this knob. It's like a tiny little knob. You twist this knob, And then when it twists this knob, this 5 volt is going to enter this analog 0. This is an analog pin. It's reading analog signals. So this 5 volt goes in this analog signal, analog pin, and when I control the resistance, the 5 volt is going to go up and down, right? It's going to change in between. But again, it's not 0 or 5 volts. It's 1, 2, 3, 4, 5 volts, or in between 0 0.1, 0 0.2, 0 0.3. I can control it. So let's just go ahead and start simulating it. And then I will check on the code. Okay, we have a longer code right now. It's going to read analog pin A0 over here. And then it's going to turn on the built-in LED. The built-in LED is over here. And then it's going to wait for a period of time based on the value that I'm receiving. But how am I going to know how much value am I going to receive? So there's this thing called serial monitor. If you work with the actual Arduino using Arduino IDE, there's also this serial monitor, which allows you to read the sensor signals on your PC. Right? Because you're measuring something, of course you want to see those numbers. So you have to use serial monitor. Serial monitor basically means that it's receiving signals through your USB, the serial port, and showing you those data that goes through this port. Okay, so right now it should be showing me some signals when I turn this guy. Okay. All right, if it's not showing me, it means that I'm not displaying it on my serial monitor. Let me do that right now. Go to text. Okay. All right. Of course, there are programs, that are already pre-built program that already demonstrate that how are you going to use serial monitor, but I'm just going to go ahead and just type some code to make it show me the value. I want to see the value. I want to see what's in the value. So easily I will be able to see what's in this sensor value. Start the simulation. And then I'll be able to read, okay, now I have 61. And then as I twist my knob, it's going to show me different value. All right. As my resistance increase, the voltage that I'm going to receive reduce. So this direction means that my resistance of my potentiometer increase. And then remember Ohm's law, V equal IR. If your resistance increase, your voltage is going to reduce. And this is what I'm measuring. I'm measuring the voltage. If my resistance reduce, I'm going to receive more voltage. And this represents the voltage. Okay, so I'm not going to dive into the detail again. I'm so sorry, guys. But this is a good platform for you to explore and try out different circuits. I'm going to spend like 2 minutes to answer your questions. So right now, guys, if you have questions, drop your questions right now. I will go through the questions. Number 1, Arduino able to generate 0.0 to 20 milliamp to 4 to 20 milliamp? Yes, it can. All right, if you check the specs, Arduino. But again, different types of Arduino, the pins will be able to generate different types, different amount of current. All right, 20 milliamp is fine. Arduino are able to generate that much. It is able to drive, for Maker Uno, the pin is able to drive a DC motor. So it is able to generate more than that. All right. Okay, from Shaman, digital 2 possibilities, on and off, analog many possibilities in between. Any more questions? Go ahead, drop the questions. If not, I'm going to continue my slides. So when can I use Arduino? Oh, okay. When can I use Arduino? This is basically asking, what can I do with Arduino? What can I do with Arduino? So there are many, many applications around you. You can look around your house and I think, what do I want to build today? Do I want to build a clock? Do I want to build a timer for my camera? Do I want to build a flashlight? Or do I want to build a waterproof, a soap dispenser? So there are many, many types of projects that you can build. You can always Google, search on the websites that I shared with you just now, but these are some of the tutorials available on Citron's tutorial. You can build your line following robot, you can build a solenoid door lock system, you can build a watering system, you can build many, many things. It's more fun if you are learning with a project. This is called project-based learning. If you are learning the fundamentals, okay, you learn the basic inputs and outputs of the Arduino. But after you understand the fundamentals, it's time for you to move on into a project. So introduce yourself a simple project. How to measure moisture on a soil, moisture sensor for soil. So just get the moisture sensor around 2-3 ringgit, plug it into the soil, and then start measuring soil moisture. You have to start with a project, right? That's where the interesting things begin. You get to explore, and then you will face different problems, and then you will get to slowly learn more by building projects. If you are just learning for the sake of learning the fundamentals, it's also fine, but it may not be able to, open up the possibilities of doing projects. So just try out, do 1 or 2 projects, and after that, you will be able to understand, I learned how to use temperature sensor. I can use temperature sensor for other things as well, right? You will be able to see the possibilities. Okay. All right. Before I move on to the next slide, a few more questions again. Let's see. How to zoom in the circuit. How to zoom in the circuit. Scroll your mouse, just scroll out, in, out. Right. If you don't have scroll, then right, you can go in and fit, but then yeah, you need a scrolling to go zoom in and out. Okay, thanks for bringing back this question. This will actually move on to my next slide, which I will straight away answer your question. Which Arduino should I get? And based on your question, what is the difference between Arduino Nano, Uno, Mega, Raspberry Pi? Arduino Nano, Uno, Mega, they are the same. They are in the Arduino family. And Raspberry Pi is a separate thing. A Raspberry Pi is a single board computer. It runs like a computer. You can use it to open a browser. You can watch YouTube using Raspberry Pi, but you can't do that with Arduino Uno, Nano, Mega. Arduino Nano, Uno, Mega is a microcontroller. It's used to build projects, to build a system. But Raspberry Pi, it has a microprocessor. It's like a computer. So 2 different things. How do I choose to fit my project? This is why I'm going to answer you. For beginners, start with Arduino Uno or Maker Uno bundles. Get those bundles with all the mini components ready in the package. Build your projects. Learn how to use Arduino with these bundles. This is for beginners. But if you are not beginner anymore, you already know the fundamental. My answer to you is very vague. I'm so sorry, but it really depends on what your project is. If you are trying to build a smart home system, how extreme are you going to be? Do you want it to have be able to control through the internet, or do you want it to be able to just use remote control? So you have to set your own requirements first before you decide what microcontroller you should get. I had a student once that doesn't have the knowledge of Arduino, but that has an idea on what they want to build. So they go on ahead and buy the components first before they decide how they want to build the projects. That's a wrong approach because you will waste a lot of money. So think about what you want to do, how you want to do it, what are the specific details of your project before you decide what Arduino you want to get. And Arduino Uno, has a basic feature for you to build basic projects. And for Arduino Mega, it has more pins, right? It has more processing speed. So it really depends what you need. Do you need that speed? Do you need that power to do this project? Or do you need, you don't need that much, so you just need enough. And the size matter as well. Maker Uno, this size, Mega, longer, Nano, smaller. So it depends on your project size. My suggestion is join a community. An experienced user will be able to give you the best advice. Just have to explain it to them what you want. All right. This is just one of the Telegram groups that we have, and please join us. It's the makers community in Malaysia. We have a lot of makers in there with a lot of experience. Just tell them, hey, I want to build a watering system for my plant. My plant is this big, and then what should I get? Which microcontroller will you suggest? And then they will ask you more details, of course, but it's better you give them more details, and then and then they will be able to suggest you. All right, let's see more questions. Can you import another library to your Tinkercad platform? Yeah, you can use libraries, importing libraries. So if you go to your code, you can go to libraries, and then you can just, include the existing libraries. Unfortunately, you can't really import library. You can import library after you download the high-end format code. All right, but there's limited library because there's limited hardware in Tinkercad. Okay, you can't import a library when it doesn't have the components to support it. So unfortunately, no. But you can use the existing libraries. Okay. And then let's see what else. If I build my own sensor, how can I simulate using Tinkercad? You can only use the sensors that is provided in Tinkercad. You can't use your own extra sensors. But again, every sensor works similarly. If you want to use digital pin, you program it digitally. If you want to program analog pin, then you just understand how to program analog pin. But if you want to use libraries for these sensors, then you have to come out from Tinkercad and then program it using Arduino IDE. All right. If the complexity increases, Tinkercad may not be there for you anymore. Right. Okay, more questions. Arduino only can be programmed in Arduino IDE, or it can also be programmed in other programming software. Arduino can only be programmed using Arduino IDE. It can also be programmed using MBlock for students if you want to use drag and drop. It can also be programmed using other software. Yes, if you have a different compiler and then you want to program it using other compiler, by all means, you can do it too. All right, I believe you will need to get the board right and then set the serial, and then you should be able to program it using different compilers. And then the Arduino programming tools do support flow-based programming. Flow-based programming, I'm not quite sure. Flow-based, you mean sequential programming? Platformio. Okay, do bring your questions. If you have more complex questions, I'm sorry, I won't be able to give you an answer immediately right now. But join our community in this gathering, and then there will be people there to answer you. Okay, summary. What did we learn today? So in this session, you already learned what is Arduino, why you should learn Arduino, where you can learn Arduino, and how you should learn Arduino. When can I use Arduino, and which Arduino you should get? I'm sorry, the last one didn't really answer your question, but I'm gonna be very honest with you. You don't buy an Arduino based on nothing based on your levels. It's based on what projects you want. Okay, so thank you guys for joining today's session. I hope you enjoyed today's session. I know you guys are waiting for the certificate. Bear with me 2 more minutes. I'm going to introduce you some of the events that is going on with Citron. Right now we are having this do-it-yourself fun project kit idea for beginners. It's a competition open for all makers, all beginners. We encourage you to build projects for beginners to learn, and it's a competition. It's an international competition open to different countries. So you're allowed to submit your ideas. You can use Arduino. You can use different types of platform. There are terms and conditions provided in this link. Just write out the link and then visit us. Join the community for this competition as well. Join the Telegram group, and you can ask any questions over there. Okay. All right. And next week webinar series, we will be having a live assembly of CR10 Smart 3D printer. If you love 3D printer, this is the Ferrari of a 3D printer from Creality. It's their latest 3D printer model. We managed to get our hands on this 3D printer, and we will be opening one box to show you guys what's in this 3D printer. So scan that link over there. Click that you are interested, or if you're going to the event, click that you're going in this Facebook event. We will be doing live in YouTube and Facebook. So join us in this live assembly. It's gonna be interesting. All right. We are trying to like set up this 3D printer in less than 10 minutes. If you are a student or a teacher, we welcome you to join our Junior Makers community. It's meant for students. It's a more light environment for students to learn in programming, in making things. So we welcome you to join in this Telegram group as well. And last but not least, I know you have been waiting for this. Okay, I'm sorry, so sorry right now. This is actually 31st. Go to this link, drop us a feedback, whether you enjoyed today's session. Go to this link, and once you complete this link, make sure that you insert the correct email. Your certificate will be sent to your email address. The link will close at 1 p.m. So send in your feedback by 1 p.m. After 1, it will be closed. And yep, thank you again for joining today's session. I really enjoy your company, your questions. I really like your questions. Some are quite technical, but I really like you guys for the interaction. I think we have more questions. Let me just try to answer it. Is Arduino can use with IoT projects? Yes, a big yes. Arduino is heavily used in IoT projects because IoT is so so trendy. People like IoT. So normally students, they will go first offline Arduino. They will learn about the basics of Arduino, and then next step, I will learn about sensors. And after that, I want to make my data available online. So the most common Arduino in IoT is ESP, ESP32 or ESP8266 or Node MCU. People use those for IoT projects, and they use the Blink app, which is very easy to use to connect with your Arduino. So go to Citron's tutorial website. Here are some links for you to try. Go to Citron's tutorial website. Do check out how can you program IoT projects for Arduino. And yeah, there are a lot of instructions over there for you. Of course, I am so sorry. I just shared the link in the comment section as well. Go ahead and click the link for the feedback. Okay, I will be here for another 1 minute. So if you still have more questions, come. ask me your questions. Let me scan through. All right, if you have no more questions, thank you guys for joining today's session. And I hope you enjoyed today's session. Join our Telegram group, and I will see you next week. Correct, bye.